This is one of my longest running projects to date. It began before I started making videos, so bear with me if the images are more stills than movies or poor quality. The reason to start this project is to be able to store and find all my different parts and projects in the pool of all things. And deep, deep down, I am the little boy that likes to press a button and the gears and motors move into motion and make things start moving, and the box is pulled from storage and delivered to my pickup point and awaiting me when I get to retrieve it. Today, I store most of my projects and parts in boxes stacked and stored multiple places like in my office. The basement is planned to be the future location of my storage system. I aim at getting something like this, and then have the robot move around in front, picking and placing boxes so inventory and organization is easier. The complete design will properly look something like this: rails on the floor for the wagon. The lifting system and cart with the box moving add-on can place and retrieve the boxes on the shelves and loading table. To start out, I split the project into parts and made some approximations on design. Rails and wagon. Vertical lift system. Charts. Rails restrict movement to a predetermined area and only two directions, but it will remove issues like collision detection, steering, location detection in all directions, and hopefully remove more obstacles than it presents. To ensure stability and avoid unintentionally movement of the shelf sections, floor rails and table will properly need to be bolted together and restrict movement relative to each other. The wagon rides on the floor rails in two directions pulled by a chain, wire, or a belt, but I will have to see what has strength and durability enough to pull the full load when I get to that step. Some issues I have not addressed yet. Motor size, gearing, and speed, dictated by how much weight it need to move. I've been thinking on how to use a webcam to monitor location and movement. To do that, I need to be able to find the shelves or boxes. I might make a target mark on the shelf that the system can use to fine-tune its location. How to make a target mark and ensure easy, reliable mounting is not solved yet. The vertical lift system rides on the wagon and lifts the chart up and down to align with each of the shelves by aim of the webcam. The movement of the lift chart is handled by chain, wire, or belts, and needs some kind of self-locking gearing. The self-locking prevents me from spending power to hold a certain position, or the chart moves out of position by itself. Of course, the system has to have built-in margins and be self-adjusting, but less uncontrolled moving parts gives less issues to fight later. Lift chart add-on is handling loading and unloading of the boxes on the shelves and the loading area. It was in this part of the project I found the biggest question so far. What boxes to use, how to move them, grabbing the sides. The more I searched, the more options presented themselves. I settled on these 4 questions. What box to use? Storage system. How to grab the box? How to move the box? After searching online, the choice fell on a plastic box 40 centimeters deep, 30 centimeters wide, and 27 centimeters high. Standard size. Ensure more availability and hopefully a wide range of suppliers in the future. Selecting shelves, if actually even harder. There is a wide variety of types, sturdiness, and materials. The shelves must be able to stand the wear and tear when moving boxed on and off the shelves. But my choice will probably be some IKEA shelves or storage shelves in metal. One of the things I have spent a considerable amount of time working out is how to grab the box. I have been investigating different methods. Suction cups that can grab the end of the box and pull it up. But this requires production of vacuum. This is another piece of equipment to buy, test, and integrate into the overall design. Ensure the suction cup gets hold on the box, being able to detect the suction holds onto the box, and ensure the force is enough to hold the box. The box has to have a surface that makes suction possible. Magnetic was my favorite for a long time, up until I had to ensure the magnet would have some metal to grab hold on, and this had to be added to each end of the box. Some of my concerns. Could the magnet destroy electronics inside the box? Would the magnet magnetize the content of the box? Would the magnet be powerful enough? Why is it always the last place you search that you find the thing you are looking for? Finally, I arrived at the solution with a little arm that will restrain the box from behind and make it possible for the chart to pull the box onto its carrying plate. This system can also handle other types of boxes as long as they have roughly the same size as the original one, until proven otherwise. To be able to work with boxes on both sides of the rail, the chart add-on will have to be able to turn 180 degrees to each side and the loading table. Pull the box from the left or right shelf and place it on the loading table, or reverse. Pull the box from the loading table and put it on a shelf, left or right. When turning the chart add-on, it needs more space to turn than the box itself, and therefore I might have an issue to cover the gap between the surface and the shelf, but let's see how it pan out. One of the next videos will be on what mechanics I used to reach behind the box and grab it, what prototypes I made, and current status. I cannot promise you a date for the next video, but I will follow this project all the way to its completion. And I can promise you I will touch disciplines I have never before worked with, like rotary decoders, building gearboxes, and I will use some of my favorite disciplines like plenty of 3D printing, multi-thread programming for the control system and embedded software programming, custom-made input-output module. Hope this video gave you an overview of the project and basic understanding of my goal. The next videos will go into more details for each part of the project. Throw me a comment if you have questions or suggestions.